The heroes of our today's release are easily recognizable among all other objects in the solar system. This is not a pizza at all, although it is similar. However, this is a handsome Io, the moon of Jupiter. It is also called the companion of fire and ice. A world where colors are changeable, like pictures of a magic kaleidoscope, rivers are filled with hot lava, and volcanoes explode in clouds of poison smoke, which played a significant role in the development of astronomy in the 17th century. Together with other satellites, Galileo Galilei discovered it back in 1610. At the beginning he united Io with Europe, mistaking them for an identical celestial body, but quickly corrected the defect. This discovery contributed to the adoption of the Copernican system, the development of Kepler's laws of motion for the planets, and the first measurement of the speed of light. Jupiter's moon was first photographed by the duo of pioneers in 1973. The primitive camera encompassed Io's polar region. In addition, the probes measured several important parameters of the object in order to form a rough idea of it. Voyagers were next to appear in the vicinity of Io in 1979. It was examined in more detail by the Galileo probes in the late 90s, having received data on the internal structure and composition of the surface. Subsequently, the satellite was observed by the Cassini spacecraft in 2000 and the New Horizons space station in 2007. And also thanks to the development of technologies, ground-based telescopes and the Hubble Space Telescope. I propose to consider the latest data on this truly unique place. In diameter, the satellite is 3,642 kilometers in size, almost that our moon is slightly larger, circling at a distance of 350,000 kilometers from the upper edge of Jupiter's clouds. Apparently, that is why the object was named after the priestess Hera, the beloved of Zeus. The image on the right shows the surface of Io, and on the left the corresponding night temperature distribution map. Red spots are areas around giant volcanoes, blue areas correspond to the lowest temperatures, for example -180 Celsius. Orange and yellow are the relatively hottest places, -100 Celsius. Yes, cool, but a light breeze filled with sulfur will be short-lived, since small spots and places of eruptions have a much higher temperature up to 1350 Celsius. Finding a middle ground will be problematic. This is due to the result of the intensive work of more than 410 volcanoes that emit various substances. Among them are silicates, sulfur and sulfur dioxide. By the way, frost from sulfur dioxide covers almost the entire surface of the satellite. Studies have shown that in the process of crustal compression, about 100 mountains were formed on the surface, changing the landscape for the next hundreds of years. The peaks of some, for example South Busala, are twice the peak of Everest. Io also has vast plains on its surface. Its surface has unique properties and contains many shades of colors such as white, red, black, green and even orange. This feature is due to regular lava flows, which can extend up to 500 kilometers. The high density indicates that there is practically no water on the satellite, although there were found small pockets of water accumulations. The lack of water is likely due to the fact that during the formation of the solar system, Jupiter was hot enough for volatiles such as water to escape from the vicinity of Io, although not hot enough for this to happen on more distant satellites. Also on the surface of Io, volcanic depressions are often found, just like in humans, although they are called putters. They are characterized by a flat bottom and steep walls, very reminiscent of terrestrial caldras, although it is still unknown whether they are formed by the collapse of the magma chamber and the collapse of the volcano summit as their terrestrial counterparts. Unlike similar geostructures on Earth and Mars, the volcanic depressions on Io do not lie on top of thyroid volcanoes, and the usual one is much larger, with an average diameter of about 40 kilometers. And the largest of them, Loki Patera, is 226 kilometers in diameter. Surprisingly, putters often serve as sources of volcanic eruptions or far-spreading lava flows, as in the case of the eruption of Paper Beach Bar, or they themselves fill with lava and become frontal lakes. Lava lakes are usually covered with lava crust, which collapses and renews continuously. But shaping Io's interior doesn't end there. At times, magma breaks out to the surface through gaps in the rubble bottom, or through cracks in the plains, creating wide, numerous lava flows, reminiscent of those seen near the Kilauea volcano in Hawaii. However, longer lava flows have been observed on Io. For example, the leading edge of flows from Prometheus moved from 75 to 95 kilometers, between the Voyager flyby in 1979 and the probe in Galileo in 1996. And just a year later in 1997, Io threw out more than 3,500 kilometers of fresh blood, or rather lava, which filled the Pila and Pater. How this happens, we are clearly shown the animation of 5 images from the New Horizons spacecraft. Here the Vashta volcano spews out matter 330 kilometers above the surface. Image analysis showed that lava flows on Io are composed primarily of molten sulfur. However, subsequent infrared ground-based observations indicate that in fact the streams are mainly composed of basaltic lava and rocks. A striking example of such processes is Messier B, an active volcano on the moon of Jupiter, located in the leading hemisphere. The volcano was remarkable, one of the largest lava flows, both on Io and in the entire solar system. Its coverage is 509 kilometers. Despite the extensive volcanism that determines the appearance of Io, the origin of almost all of its mountains is not volcanic. Most of them are formed as a result of compressive stress in the lithosphere, which lifts sand, often tilts pieces of the satellite's crust, advancing against each other, like giant ice flows. That is why almost all mountains on Io are in some stages of destruction. Large landslides are widespread at their feet. It appears that shedding is the main factor in the destruction of mountains. Believe it or not, a relatively tiny cheese ball, Io plays an important role in shaping the magnetic field of the giant planet Jupiter. The fact is that the magnetosphere of Jupiter absorbs gases and dust from the thin atmosphere of the satellite at a speed of 1 ton per second. All this matter, depending on its composition and degree of ionization, ends up in various neutral clouds and radiation belts of the Jupiterian magnetosphere, and sometimes even leaves the Jupiter system altogether. Interestingly, the moon Io is surrounded by a so-called atomic cloud of sulfur, oxygen, sodium and potassium. It stretches to a distance from its surface equal to about 6 of its radii. These particles are transferred from the upper atmosphere of the satellite. They are activated due to collisions with particles of the plasma torus and other processes in Io's Hill sphere, where its gravity prevails over Jupiter. As you might guess, Io is not at all like most satellites of gas planets, which often contain huge masses of ice. Io's moon is composed primarily of silicates and iron, just like the terrestrial planets. Moreover, it is incredibly active in its depths. Modeling the internal composition of Io shows that the mantle consists of at least a magnesium-rich mineral firstrite. The composition of this particular mineral is similar to the composition of meteorites, alchondrites. It is obvious that the ratio of the concentration of iron and silicon there is higher than on the Moon or Earth, but lower than on Mars. Recent studies have shown the presence of a magnetic field on Io, which requires an ocean of magma at a depth of 50 kilometers. This layer is estimated to be 48 kilometers thick and makes up about 10% of Io's mantle. The temperature there reaches about 1,500 Celsius. However, it is not yet known whether this 15% melting, with the condition of significant amounts of molten silicates, in this incredible ocean of magma. Yes, Io is a bright and amazing world that has no analogues in the entire solar system. Active volcanism on a satellite the size of our moon is simply amazing in scale. And the futuristic photographs of the satellite's surface, obtained by many spacecraft, makes you plunge again and again into the atmosphere of this distant and mysterious world.